Okay, good morning, and thank you for coming.
Oh, yeah, sorry.
Let's start on time on this panel of 3D, three-dimensional, and let's say digital technology. First of all, I would like to thank the organizing committee and Daniel Lee for giving me the privilege to share this session. Yesterday we had a session on exoscopes and digital microscopes, so let's say that it may serve as some sort of introduction, although probably here we're speaking about different things. First of all, I have nothing to disclose. I have no relationship with any of the trademarks that we were dealing here. And first of all, this is my co-chairman, but unfortunately, Professor Thomas Leonard would not be able to be here because of a problem back in Germany. It's a pity, but I will try to do my best to try to share the panel. My name is Miguel Aristegui. I come from Spain. I'm head of the ENT department of the otolaryngology department in the Hospital Gregorio Marañón in Madrid. And let me introduce you. We have a talented, outstanding panel mixed of young people and experienced people that have at least have a high interest in the field we're going to manage. So we have Stefan Plonke, is a professor and chairman of the ENT department in Halle-Wittenberg in Germany. We have Nicholas Jufes, is associate professor coming from Sydney, Australia, and he is also a member of the International Working Group of Endoscopic Neurosurgery. You have here Qingguo Chen, is head of the otology department and director of the Communication Enhancement Center in Taoyuan, Taiwan. We have the young people. Samuel Barber is here, is resident of otolaryngology in the University of Arizona in Tucson, Arizona, here in the United States. And of course, we have also a local representative here coming from Boston. Elliot Cousin is a neurotology fellow in the Harvard Medical School. I think we have, as I told you, a talented and very interested in the topic panel. So probably we are going to be speaking about 3D. That is the idea.
Yeah.
And should we be speaking about the present or the future? So it's I mean, we're not going to show you 3D. You're not wearing glasses. So that really tells you that we are speaking more about the future than the present. Should we speak about 3D or probably about the improvement of quality of image? To 4K, we're using 4K, 8K is being implemented. Probably in the short future, we will be speaking about 16K. Someone told me that the resolution of the eye of the human being is between 8K and 16K. So it has no sense to go farther beyond, but certainly it is important to speak about it, and probably technology will develop very quickly in the following years. And probably we will mix them. I mean, it's not 3D or augmented definition. We may put them together. So we may probably speak about the need to use 3D or not 3D, and this is one of the topics. Of course, we are going to speak about exoscopes, digital microscopes, 3D endoscopes, and some that really looks like a future augmented reality incorporated or implemented in this one. My personal experience is very limited to exoscopes, but really I felt like a rock star singing in the audience there, taking that exoscope with me. But I've tried both of them that are, or some of those who are being implemented now, and I will just tell you roughly my short experience. This is the first case, and you can see how we are working here. I cannot use it. I don't know why. What is the problem? Okay, let me see if this is a problem. Why? Wait a minute. Something happened. Okay, you're very lucky. I cannot show you this. That's a pity. Well, here you can see, and let me see if the other one is going to be shown or not. So this is the way we're working. We're looking to a screen, and hopefully my colleagues in the panel will show, but this has been working all the time. And this second, and let me see if it's working. Again, I'm so sorry about this, because this was done last week. This is a case of translabyrinthine removal of vestibular schwannoma. I did that the first time I used the exoscope, and I did the whole approach. I ended the approach and I say, okay, now I'm going to work over the tumor, bring me the microscope. And that's what I did. Now, the second time I was using another exoscope with very high quality, and really I did the whole approach from skin to skin, removing the tumor, and I have really some appreciation that I would like to be discussed. I'm so sorry, but that will give more time to my colleagues, and I will see if it's possible to solve the problem, and at the end I will try to show you the videos. So about exoscopes, we have Elliot Cousin, who will speak about using them 2D or 3D on it, and may bring some discussions about the use of it. We will speak about digital microscopes against or versus the optical microscopes, and Stefan Plonke will show us the importance and how the digital microscopes have now some possibilities. I think probably more than 3D, we're speaking about digital technology and how it could be implemented or not and can be used. Qingguo Chen will speak about 3D endoscopes. It's really worth to use is the size and the weight of the endoscope is really adaptable to endoscopic ear surgery. We are working about a very narrow external auditory canal sometimes, so it's really very difficult. So it's interesting to hear them about this. And finally, Sam Barber will speak about that augmented reality. How can we incorporate this technology to any digital device that we may use, 3D or not 3D, and how it could help us in cases of pathology and also otoneal surgery. So let's start with this. I think, Elliot, we'll move this, and I will try to solve the problem with the videos. If we have time, I will show you afterwards. So let me change this for you. I think I have 30 presentations.
Well, good morning, everyone. So my name is Elliot Kozin. I'm one of the neurotology fellows at Mass Eye and Ear.
Thank you.
I want to discuss a little bit about our initial experience using exoscopes for otologic surgery. And this was some research that I did with Sullivan Smith as well as Dr. Lee. I apologize. Some of these slides are some data that you saw yesterday, but for those who were not in the talk, I think it will be new and a refresher for those that saw it. So I have no relevant disclosures. So over the next 5 minutes or so, I'm going to discuss a little bit about the equipment, room setup, ergonomics of exoscopes and how you can use it and maybe some of the benefits, its role in teaching, and then end with the summary. So just to recap, these are the 3 different technologies that are now largely available for us to use. We have the operating microscope, the traditional endoscope, and then the exoscope. So the operating microscope, as we know, have binocular vision, just given that it is a microscope. The traditional endoscope is not typically 3D, but it can be. And exoscopes come in 2 different varieties, both 2D and 3D. The operating microscope and the exoscope have similar focal distances, about 20 to 50 centimeters, and the traditional endoscope is obviously much nearer, about 1 to 3 centimeters. Importantly, operating microscopes use a direct line of vision. You need to do bony and soft tissue removal to see the surgical plane, and that's not necessarily true for endoscopes where you are allowed to see around corners. 3D exoscopes and exoscopes that are 2D also are largely line of sight, but they have potentially improved optics. So these are the essential components of an exoscope for those that are not familiar with it. You have a camera unit, you have the holding arm, you have a control knob. This could be a hand piece or a foot piece. Some exoscopes will move on their own. And then you have a monitor that's not shown here, typically a high definition 4K monitor. This is the setup that we use at Mass Eye and Ear for exoscopes. It's actually fairly similar to what we use for endoscopes as well. So this is for a right-sided ear case. You see the surgeon on the right side, assistant surgeon closer to the feet. Opposite to the surgeon, you have the 4K monitor. This, again, is at head level, so you're not straining your neck at all. The next, probably most important person is the scrub nurse that is also opposite the side of the surgeon, able to hand instruments over the bed itself. The anesthesiologist is next to the assistant. And then other things to note that are in the room: the operating microscope. This is always available if we need it. It is not draped on most cases. We also have facial nerve monitoring, and then a 2D monitor that sits behind the surgeon so that the scrub nurse or the assistant knows what's going on as well and can sort of follow along. So this is what it looks like in real life. Typically, it's a little bit dark, but usually for these cases we do dim the lights. So you have the surgeon, that would be number 2 or so, who's looking at the 4K monitor. And then on the opposite side, you see this other monitor that the scrub tech or scrub nurse is able to follow along as well. When we do skull-based cases, you can see it's shifted a little bit where the surgeon is more at the head of the bed. And I think one thing to note too for exoscopes is really, I'll just move, is how much working distance there really is between the camera and your hands. And so when the nurses are passing instruments, there isn't necessarily that sort of small couple inches of space to hand instruments. So this is a slide that Dr. Lee showed yesterday. Our experiences to date, it's actually a couple more by now. So about 11 cases, really wide variety of ages. This was published in the White Journal, so you're able to see it there if you're interested. Visualization methods were mostly the VTOM and the Orbi, no complications. And really just to summarize, so we've done a couple CIs, a couple canal wall down, some skull base, as well as canal wall up surgeries. And many of these were done in combination with an endoscope as well. So I think one of the main things when you consider exoscopes is the ergonomics. And I think this is Dr. Nick Dewyer. He's one of my co-fellows at Mass Eye and Ear, and he has pretty good, ergonomics using the microscope in that position, relatively neutral position of the neck, and you could see that in contrast to the exoscope. But I think when oftentimes when you hear people talk about microscopic surgery, that if you were just in a neutral position, if you're aligned perfectly, then you're just not going to have any neck strain. And I think that probably is just really not the case. If you're sitting with your neck in the same position for hours on end, even if you are in the perfect position, you're still going to have neck strain. And I think that's really the concept of heads-up surgery, where you're not locked into one position throughout the entire case. So we did a survey, this is an N of 3 of different surgeons, and they looked at things like ease of manipulation, lack of neck strain and fatigue, ergonomics, image quality, and just on a visual analog scale. And it was really this lack of neck strain and fatigue that stood out compared to the operating microscope. And I think in addition to some of the ergonomics and strain is people will often talk about teaching, how good it is for teaching. And I think when you talk about teaching, you also have to talk about teaching and communication. They really go hand in hand. You're not just teaching the residents or fellows or trainees or observers in the room, but you're also communicating with everyone at the same time. What you see is what everyone else sees at the same time. So exoscopes versus microscopes, some initial impressions, the compact camera unit. I think this is also really interesting for those that might go and do mission trips, those that go to developing countries and can't bring a big, bulky microscope. You could potentially bring one of these smaller exoscopes with you in the same way that you might be able to bring several endoscopes. Potentially superior ergonomics and less neck strain. Again, it's really superb for teaching and communication. Those go hand in hand. Disadvantages, inadequate lighting in narrow spaces. This was especially true for cases that we did cochlear implantation. After we did the facial recess, it is a little bit dim in there. And for those that don't have great optical zoom, it can become a little bit pixelated. I think when thinking about exoscopes, really want to ask, what is the optical zoom? I mean, similar when you buy a really nice camera, whether it's SLR, you know optical zoom is really pivotal. Anytime you go to digital zoom, you're losing some pixels, you're losing some resolution. So this really is key, and I think is where the field is going to grow. And then finally, with all new technology, there's a learning curve. For those that do endoscopic ear surgery, I would say the learning curve is not significantly more than what you're already used to. You're already used to looking up at a screen and having your hand sort of in a fairly standard position. But for those that are going to go directly from a microscope to an exoscope, that's where you might begin to see a little bit of a learning curve because your head is in maybe a different position than you are used to normally. So in summary, exoscopes, especially 3D exoscopes, are an emerging viable alternative to the operating microscope. And I didn't talk about too much here was some of the 3D versus the 2D exoscopes. And one thing that we have to consider with exoscopes is they really are stationary. So for endoscopes, we're constantly moving them in the ear, and that allows for this parallax effect. Basically, your eyes are moving with the endoscope, and so that provides a sense of depth perception. And so 3D endoscopes, I would argue, are less necessary than potentially 3D exoscopes, where you really are stationary. It can be a little bit challenging when the exoscope is in one position and it is in 2D, especially, say, if you wanted to do a cochlear implant. Potentially superior ergonomics and teaching utility, and along that with communication. And then really we do need more longer-term studies with many more surgeons using them to really understand where these might come into play and how they maybe one day may replace the current operative microscope. So with that, I'll thank you and head it over to the next speaker.
Thank you a lot, Stefan. Try to keep on time.
Yeah, thank you, Miguel, for the kind introduction and for inviting me here. I would like to present some personal experience or my experience with a fully digital 3D microscope, which I am now using for more than 1 year. I have given my advice to the company who developed it, but I didn't receive any money or anything, so I think I don't have anything to disclose. I'm not allowed to point out the name of the company, but you can ask me later if you're interested. So you see the black area here. So the basic principle of the microscope is fully digital. It has a digital binocular. It's high definition and 3D. The surgeon, the assistant, and the recording all have the identical image, which I like very much because I'm using the another, I just wanted to say a name, another recording system with our other microscope, optical microscope, and there the frame of the picture and the frame of what I see is not identical, so which is problematic for video recordings. Then also the image chain, meaning the chip, the camera, the illumination, and the software, all from the same manufacturer, which is actually known from other cameras. That means we have an optimal adjustment of the electronics and the software to each other, which is actually something that's very helpful compared to if you buy different components from different manufacturers together. Then there's additional information can be visualized in the binoculars through the picture-in-picture technology. So, for instance, preoperative CTs, MRIs directly from the information system, including scroll function. You can go through the images and you can zoom into the images. Also, you can incorporate endoscopic images simultaneous to the live microscopic image. So you can actually have the around the corner view in your binocular. Then, which is very important in many departments, also in our department, so there's often the situation that I have to supervise younger colleagues, and then I scrub in and I scrub out and try to put my finger somewhere and not making anything unsterile, which is really nice. Here you can actually, I can draw things on the screen, and the surgeon sees what I draw in, if I make an arrow or a circle, important structure, and I can point out dangerous structures or important things to do. And the surgeon sees them in the binocular, which is very nice. The illumination is LED, is long-lasting compared to other xenon lamps. It's colder, And I can see this with the chorda tympani, for instance. You know, it also gets dry here, but it takes longer to get dry. So, and if I zoom in, usually the light goes down in other microscopes we use to decrease the temperature. And here, the working distance, if I get closer, I mean. And here it's actually getting lighter and I can see more. Yeah, and there's a second illumination channel for shadow reduction. You can choose whether to use this or not. Then, of course, we have a nice possibility of teaching. Due to the good resolution, you can put it on large 3D screens. Then there's research projects going on with it, 3D measurements, acoustic reflexes, tissue deterioration, contrast enhancement, telemedicine. So one is supported by different funding sources on telemedicine, tissue differentiation, and augmented reality. So, for instance, the video streaming, we use this successfully for teaching medical students. So sometimes in the ENT lecture, they get a live stream from the OR to the lecture hall, or we have the Halle Surgical Week. So in November in the evenings, we transmit live surgeries to the medical students every evening for 2 weeks. And there's a superb quality. But also we have a project with the Army, with the German Army, for consultation, video consultation through like telemedicine. To evaluate whether it's possible that I can actually supervise other surgeons or help them in a difficult case somewhere else. Then there's different technologies on multispectral imaging. The strength of the company is on camera technology, but also post-production. So the question is, by filtering color information from the signal, can you actually better differentiate cholesteatoma or facial nerve? So there's research projects going on. Then measurements. Some people always use the same length of a stapes prosthesis, or in my experience, most of the porps and torps are rather too long. So when I do maybe 95% revision. If it's a tympanoplasty, it's usually a revision tympanoplasties. And my experience is often the prostheses that are put in there, porps are too long. And maybe we can improve this by better measurements. And this is, since everything is digital, you actually can choose 2 points and it's calibrated, and you can measure the exact distance between the incus and the stapes footplate, or between the stapes head and the estimated position of the tympanic membrane. Yeah, and then, of course, as teaching, we use this like now since 2 years in our ear surgical courses, and the teaching experience is just superb. Our anatomy department, where we do the wet lab, is also the location where the participants sit, and the hospital is about 3 kilometers away. So I do the surgery in the modern part of the hospital. The participants sit in the old anatomy department in the city center, and we have the 3D image. And yeah, the feedback is just superb with the teaching experience for orthologic surgery. And then there's other things, research projects that would be an unstabilized image here on the left side, and then a stabilized image for measuring acoustic reflex in cochlear implants, for instance, automatically. And this is a research project that's just in its just a baby, so not just start. I mean, so reduction of reflections during use of KTP lasers. Yeah, I thank you for your ear, and if you are in Germany, you can come by and can visit us using the microscope, and you're always welcome. I also would like to welcome you in 2 years to the 100th anniversary of the German Society of Otolaryngology Head and Neck Surgery. Thank you.
Thank you. Thank you, Stefan. Yeah, we'll leave questions for the end of the session.
Good morning, everyone. I'm Jingo Chen Kang from Changge Memory Hospital, Taipei, Taiwan. Today I will focus on the computer-assisted 3D endoscopy system, which is applied in the ear surgery. I have nothing to close here. As we know, there are many more and more authorities just adopt the endoscopy in the ear surgery. However, we just have some challenges about the ear surgery, just like single-handed, or maybe the operation time has been increased, and also there's maybe a long-term learning curve. Today we will about the stereoscope view in the ear surgery. About the stereoscope vision for actually distance from the objects, we just suggest direct use the endoscope to see what you have to operate, and remove the scope forward and backward in the ear canal. And also today we will discussion about the 3D endoscopy images. And as we know, there are three kinds of core approach to from our eyes to provide the 3D vision to get a depth perception, such as oculomotor course just from the convergence, and the monocular course just from one eye, and you can see the relative information between the neighborhood or the relative structures. And as usual, we use the binocular course just from the both eyes. And according when you use the both eyes, you can have a binocular displaces that is can benefit to see the distance in depth, and so angle of the distance you can get a 3D image. In this case, we just have three technical aspects of 3D endoscopy. First is binocular endoscopy, which the image was obtained from a double channel scope, and so you can see the diameter may be larger. And the other one is inside-eye technologies, which the microscopy array of lens in front of the monocular scope. And both of these devices just has a larger diameter, maybe larger than 4 millimeters. And today I will show the image processor, which is computer-based 3D endoscopy image. There is no limit by diameter of the endoscope, and no need to change the whole system. And you can see the basic principle of this system. The 2D image is just obtained from the monocular scope, and the image is just temporary. This is called a database. Then the image is just input to the right eyes, and after this, you can see from the machine, you can process, Okay, gain the images to the temperatures storage as image for the other eye, then we can get a 3D image. So you can see what the Okay, you can see in our operation setting, the operator can just see the conventional 2D system and also 3D image system. Then the observer just see the same monitor. So totally, we included 18 cases in our study, and just one surgery performed the ear surgery, and also the 35% participant just has a questionnaire. We have three questionnaires for this study. First, the most of the participants just agree the 3D imaging system can appreciate a 3D image vision, and also provide a period depth perception, and let's feel the visual fatigue just because he just feel asleep last night. And that's the demographic of about our 18 patients, and you can see from the usually ear disease just from the corneal otitis median, or also the atelectasis, and even congenital cholesteatoma in the age of 2. And we also can use this system. And however, about the procedure we have performed with this system, you can see the temporoplasty to the atelectasis, and even the the stereotomy with piston, and the 2 cases about cochlear implant surgery. We can use this system. We also compare the operation time needed for COM and keratoma. Between these 2 systems, 2D and 3D endoscopes, there's no significant prolonged operation time in between both systems. So we got a conclusion that with the computer-based 3D endoscopy system, there's no need to switch to conventional 2D endoscope, and also no prolonged operation time and no perioperative complication. The most important is no mortality. I think when we talking about the 3D endoscopy, I think it can offer the superior measure of the surgical anatomy, just like Professor showed, and you can see no perception of time delay. However, I think the most important for this system is for education. The relative information I just published in the European icon, you can see not declared in the hospital. In my opinion, I think when we talk about the 3D endoscopy surgery or anything just like exoscopy or digital microscopy, I think that depends on what you have, and if you do more and more cases, you can get some skillful or experience in your surgery. I think it's most important thing is for happiness of the endoscopy surgery. As a member of FWES and also the POGIS, I just want to ask you and thank you for your attention and welcome to Taiwan. Thank you.
Turn off the sun.
Good morning. My name is Sam Barber. It seems my credentials have disappeared, but I'm a resident at the University of Arizona, and before that, I was a research fellow at Mess Eye working with Dr. Dan Lee. And today, I'm going to tell you about how we could use augmented reality for middle ear and lateral skull base surgery. It's really more of an informational session to go over the past, present, and then what may be existing for us in the future, how we may use it into our surgical practice. So I will get to presentation mode. I have no disclosures. So to give you an outline, I'm first going to tell you what augmented reality is. I think it's best. Some people have varying experiences. Some people have not really heard that much about it. So I want to bring everybody on the same page first. Then we'll talk about early examples of augmented reality. The history actually dates back a little bit further than some of you may believe. Then we'll talk about current methods for AR, what's been out there, what's been published in the last few years, and then we'll discuss what the future applications may be for us. Is there a possibility to integrate this in a surgical practice? So talking about augmented reality, in general, it's just the ability to place virtual models or virtual objects into the physical realm. So it combines with the real world with the virtual world. Most people are able to understand this through pop culture with the Pokemon Go is probably the most popular example of this. And really any computer, tablet, or phone, anything that has a camera with a live display that can use 3D models can be used for this. But in order to put the 3D models on, it can be something that's coordinate-based, that can be tagged with different markers. You can even have like a global GPS-based, like a cloud-based marker system where you could download entire catalogs of things that are already put out there in the world. And so really the extent to which you can track things is pretty remarkable. And then in terms of medical imaging data and how we can use it, we can take CT imaging, we can take MRI, all sorts of different structural information, and convert that into visual information for us. But going back a little bit in time, this was one of the first articles that I could find. It was augmented reality systems for medical applications. And so taking a look at what some of their main body text was, they said that the user's view of the world is enhanced in the form of labels and 3D rendered models. These are kind of all things that we're looking to do currently. And they're talking about how they were able to achieve this through these things called transformation modules. And they have reference to a world coordinate system. And it's all things that are used right now. And so I was trying to figure out how far this dates back to, and it ends up being 1998. And so a lot of the main body text is essentially the same sort of hopes and wishes. And it seems like we've really kind of been talking about this a lot, but only in the last few years have we made any progress with it. And actually going back to the first head-mounted display, one of the headsets that people now wear around, this actually dates back to 1968. The very first setup they had was actually quite similar to what an HTC Vive or the original Oculus Rift is now. So it's kind of remarkable. They're using very similar methodology for the same thing. In terms of what does the future hold for AR, another article on surgery, this was similar rhetoric talking about extending to robotics and simulation. This sounds like a paper from this past year. It says that the expert surgeons can benefit from more complicated cases and potentially do more operations that were previously not feasible, and then for beginner surgeons be able to help navigate. And they're saying that this has really rekindled interest in surgical anatomy here. And this was also 2003. So really it's been talked about for a long time, but I think there's been a lot of bottlenecks that have kept us from making advancements. And really, in the past couple of years, we really made strides. So to give you just a sense of what's been done in the realm of otolaryngology, there's a review article that was done by a colleague, Kevin Wong. He actually had a pretty nice paper here that did a rundown. In terms of neurotology, about a quarter of the different papers over the years from 1998 until 2018 were within this realm. About half of them used interoperative navigation, and about half of them were with endoscopic approaches. In terms of tracking and registration, to explain what that means, tracking is really how you keep track of the world environment and calibrate that with the virtual models. So you can do optical tracking, or you could do, so that was 38% or 39% of these papers. The other would be like electromagnetic, the same sort of stuff that you can think about with commercial navigation systems for FES and for trans or lateral skull-based approaches. And then in terms of registration, it's how they're able to recognize the objects that they're tracking. So almost half of these were using fiducial markers. I know there's a lot of talks that were done yesterday and potentially today about different strategies. There's and we'll talk about those in a little bit as well. One of the more pivotal papers that I found in this lit search was interesting. It was using a Da Vinci robot to do an augmented reality assisted, essentially, cochlear implant. And when you go through it, I mean, not many people use a robot to do this procedure, but they were able to kind of use that technology and piggyback on a lot of the infrastructure that was built into the camera system in order to do that. So it's one step forward for proof of concept, and then the goal is if you can demonstrate this, then you can possibly adapt it to other types of camera systems, like other just standard endoscopes or other microscopes. And two other papers that I found that are using different strategies that I wanted to discuss. One was a paper that was coming from Washington University, St. Louis. And this was pretty recent. This is looking at a cadaver model being able to overlay imaging from CT. And they used surface anatomy in order to register with the real time. So you have the different layers. You have a soft tissue that was separate from the bone, that was separate from all the different nerves, vessels, and arteries. And one thing of note here, usually more information is helpful, the more points and the more complex geometry you get. But it turns out that as you have more data points, they all get compared to each other again and again. So the more data points you add, it keeps actually shifting. Sometimes it can lead to less accurate tracking over time. And so another way to do this is just to piggyback on existing commercial navigation systems, like in this other paper, that was a +1 paper, as below. And I understand that the endoscope's not in the correct location, it's in the nose, but so they're on the right track at least. But what's here, it's a different design problem that they didn't run into with the HoloLens. So the HoloLens, they've already figured out how to project the 3D model based on the interpupillary distance. So you don't have to figure out how to distort or account for distortion of the image so it lines up with the real world. However, with any sort of endoscope camera, you have to account for the wide field of view. With like a 0-degree endoscope, typically it's about like 90 degrees or so. So your virtual camera now has to mimic the real camera. So a lot of that can take a lot of time to develop. Fortunately, a lot of things like game engines have the ability to create physical camera emulation. So if you put in all the same information as the manufacturer's camera, typically you get very close. But there are a lot of subtle nuances. Sometimes there's a lot of shortcuts that are done in the manufacturing process that it actually takes quite some time. So I can imagine that these people spent a lot of time getting that refined. But in terms of whether you're wearing a headset or whether you want to integrate this into an existing heads-up display style, I think it's important to note a recent paper that came out. This was the news article, just saying that the HoloLens is not fit for surgery. The short of it is just that there's a few things that people didn't initially think about until they have a user experience. And so although it seems like you'd be able to just use both systems at the same time, you're actually kind of processing two different sets of information simultaneously, even though theoretically you're now combining the two. So people were noted to have a lot of strain and fatigue over time. And interestingly, people performed worse with fine precision tasks than they thought they were. And this was due to the fact that their accommodation for depth was different from the information that they saw on their screen in front of them versus the real world that was actually further away. So although there has been accurate tracking, no matter how accurate the registration is with the HoloLens, the user is still going to have the human element, which is going to present a problem. That being said, there's a lot of funding opportunities and a lot of push to use the HoloLens for research and development for prototypes. So I think there's better support for that. So I think if people are interested in this type of research, you can do that just to have a working prototype and then shift it to some other system in the future. So again, with future applications, it's going to be the difference of using these heads-up these smart glasses, or if you're going to use a heads-up display and integrate it into your current system. And then secondly, the question is, how do we get all these images lined up with the real world? Is this going to be fiducial-based versus surface-based? And so again, there's actually a hybrid tracking that seems to be falling into favor, where you can use your standard commercial navigation and then you can calibrate it or adjust it based on additional surface information. So I guess the answer in the end is you might be able to use both of them to get further. And then if we're able to combine existing technologies that we use now, there's going to be less of a learning curve in the future. So rather than have to learn all of this, all of these new techniques and then bring entirely different equipment into the operating room, I think if we want to implement widespread use, it stands to reason to just piggyback on what we already have and just have a new layer or a new feature within that. And then just two other things, looking.
Just a minute.
What's that?
1 minute.
Okay. This is the last part here, just looking at two examples of things that have been done in the past couple of years. One is just for the sake of preoperative planning, and this was a project that was done as a medical student when I was still at Mass Pioneer under Dr. Danley and also with Elliot Cozen as well. And this was looking at surgical planning for a petrous apex cyst. And with an augmented reality app using this target-based image on a cell phone, you're able to move the model around freely and see all the 3D anatomy however you'd like prior to seeing the anatomy in real life. And so that's one opportunity to do three-dimensional visualization that you can't get other places, but it still doesn't really help us for augmenting existing structures. So more recently, this was actually from a poster presentation yesterday. This is proof of concept, taking an endoscopic view and putting a live endoscope feed into a game engine, and then using that CT-specific anatomy to overlay an augmented anatomy over the live view. So this has been done in the past with some other projects, but for here, it's actually looking at, this is a 3D printed model. Then the next phase would be to do more commercial tracking and to use like a cadaver dissection. And then you kind of keep going up the chain from there. So I think at least here we're able to prove, and I'm not sure based on the lighting how well this shows up, unfortunately. But essentially you have a fusion of the obstacles between the two. You're looking at a transcanal view here. And I guess it's kind of tough there with the lighting, but you're able to see the obstacles that are fused, so you know you have the same exact vector and the same perspective. It seems pretty dark here, but you normally have the remaining aspects of the incus and the malleus. But importantly, you're able to see all of the nerves that are passing through the facial nerve in the Philippine Canal and the basal turn over the promontory. And if you're going for a subcochlear window, you actually are able to see the location of the jugular bulb and the internal carotid artery. Sorry that's a little bit dark on that, but the poster is available for review at the various stations. But thank you for your time.
That's great, thank you. I hope we have some minutes for discussion. We have coffee time afterwards, so we can have. Now, now that none of the organizing committee members, Daniel, please leave the room, is hearing me, I should say, I have to make a confession. I'm not a 3D fan, I should say. I have been trying all of them for a lot of time, and I have associated 3D to headache. I don't know why. But really, I was surprised when I used the new Exoscopes. Really, I didn't have headache, and the 3D has improved quite a lot. But to my mind, I think we are not discussing is some sort of confusing to see all this technology and which is the adequate one or not. For me, probably I would ask you now, and Nicholas, I would start with you. Do you think 3D technology, we will use 3D technology, or it is enough to have 2D technology with a really high quality 8K or 16K, and we won't need to use glasses to be aligned with a monitor or whatever it is? What do you think about 3D technology?
I kind of agree with you. Like my experience with 3D technology so far has been that it becomes a bit more cumbersome and it's not that good versus non-3D technology. I think, having said that, there's a difference between what we've been discussing today with endoscopes and exoscopes. So if you look at endoscopes specifically, there's aspects within the use of endoscopic technology that mean that it doesn't really become that advantageous to have 3D. And the things here are linear perspective. So when you're looking at an endoscopic picture, the way all the lines converge in the distance. Shadowing, so the way that the light casts a shadow over various objects and the way the shadows interplay. Textures, the textures of the environment you're in, and then obstruction, one structure in front of another and blocking it. Now, those four things are the things which with an endoscope will only work if you're moving the endoscope around, which is a key part of using an endoscope. When you've got an exoscope, it works more like your operating microscope where it's fixed in a position. So those aspects you don't really get. So I think with an exoscope, the advantage of having a three-dimensional image is much greater than with an endoscope. There's also prior knowledge, and that comes into both of them, and that comes from your experience with cadaveric dissections, operating that you've done so far, and so on. One of the other things I think is looking at 3D technology in other applications outside of medicine. So look at the movie industry, for example. 3D technology has been around for 20, 30 years
And
plus
we're
since
not
it first
using
got
it.
introduced.
And we're not using it.
Exactly.
Yeah.
And it keeps coming back, and there's been these relaunches with like Avatar, and this was going to be the next big 3D thing, and that was 3D was going to launch from there, and then it hasn't. And 3D televisions and all of this, people try it, people have it, and then no one really uses it because you put on the 3D glasses and it's great for the first couple of minutes, and then your eyes kind of accommodate to it, and it becomes like a 2D experience, so no one really uses it. And I think there's room, and there's clearly applications within not just the medical industry in general, but in otology. The technology will just keep getting better and better. So it's not like, and I'm not going to sit here and say the technology is terrible and we're never going to use it, and what we have right now is a state of the art, because that would be very naive, particularly with being at a World Endoscopic Congress. This is what we're arguing against, that people shouldn't be so naive out there and go, well, endoscopes aren't the way, operating microscope is the way we should always stay, and this is how we've always done it. So in the future, there's certainly all of the talks that we've heard so far today, there's amazing applications that I think are just going to keep developing. But personally, right now, particularly with endoscopes, which I guess is the focus of this Congress, do I think that 3D has a role? Not right now, no.
Yeah, but let me show you this very shortly. I will run it quickly, but I want to show you this is one of the, I finally solved the problems. This is a translab done with an exoscope. And really, of course, we were working on 3D, and now I'm showing you the 2D. But the quality of images is quite good. For me, it's not only that you are able to work on it in a different way, with a different way of magnification, but really, what really impressed me is that you have enough light even when working intradurally, and you will see that in a few minutes. I mean, you can see, it's like if I have recorded it through a microscope. It's the same. We have been speaking about ergonomics. I'm not so sure. I mean, I've just done a couple of cases, but for me, the microscope, if you're really well seated, you won't have any problem with that. With the exoscope, the problem is that you may find yourself in between the exoscope and the field, and so that obliges you to ergonomically adapt to that. But I think those are things that may be overcome. You see, you're in the depth. For me, at the beginning, the 3D was probably overexpressed, and when you're getting inside the CP angle and very deep in the field, the problem is that probably the depth of the 3D is not as real as you will have with a microscope. But I could do, and look at the illumination. You can see the eye very well. There are not hidden areas, and you will see at the end, after removing the tumor, you can see very nicely the facial nerve, you can see the brainstem. Look at the light over the fifth nerve, and you will see at the end that really there is a lot of light there. You need a focus, and the focus system probably is something that requires to be improved. But I want to show you, because you can work in very deep areas. So let me go ahead, and I will not discuss about this, but I would like to come here. So in fact, we are, to my mind, we are not speaking about should we use exoscopes or should we use microscopes. The problem is we have different digital magnification systems, and which is better or not? I mean, all of them are cameras and are digitally and can be implemented. And you have probably in the race, Stefan, probably the microscope has more things implemented now, filters and navigation and everything. But as Sam has raised up, you may implement even augmented reality to any of them. So my question to all of you, and very shortly, please, which system do you think in the future would win this race of digital technology? Because all of them may be implemented to 8K, 16K. All of them may use 3D. All of them may use navigation, filters, measuring devices, whatever system, augmented reality. So which do you think ergonomically could be used? And we are not speaking about endoscopes now, because this is a different question in an open field. Stefan.
With respect to the 3D, I would like to say that I love my 3D microscope, and I love to have a 3D picture. My residents and the attendings love to have a 3D picture to observe the surgery, and the people participating in our surgery courses don't get tired even after 6 hours of surgery. So I don't have the experience, a negative experience with 3D, and I think for teaching otologic surgery, I think 3D is
for
very good.
educational, it's
Second thing
doubt,
is,
no doubt.
I'm
Yeah.
pretty sure the future machine I will have in the OR will let me start surgery with an exoscope, continue with a microscope, and use the endoscope for looking around the corners. I think the perfect machine has all the three options. That's what I think.
But it's the same. I mean, even the exoscopes, they are mentioning that they are microscopes. So you can call whatever it is.
Yeah,
It's a magnification digital system.
I think
whatever it is.
the ergonomics. I think one of the main points is the ergonomics. I met an American and U.S. chairman from the South in Germany last week, and he got neck surgery. And I think he said there's knowledge about that after 10,000 ear surgeries, you have a problem. So I got a little afraid, and I will try to do more.
When you use the digital microscope, you put it in between. I mean, you place it like a conventional microscope or not, or you use it out of the
Well,
field?
so far I'm one of these
You're not using
people that look. I'm only using the microscope, and maybe I do a lot of like Cohen's 1 or 2A procedure. So I use the endoscope a bit sometimes, but I'm usually like an old man in front of the microscope for years now, and I'm getting afraid now. Yeah. Because
okay,
I'm getting paid.
you explain it, Elliot, about 3D, high definition, any system, digital system. What you think about these rays
I think
on technology?
seeing some of these exoscopes and even some that are not even on the market yet, the optics of some of these things are unreal. and there's nothing in front of your face like a microscope. These things can sit behind your shoulder and sort of, as you move, they move as well, or you use your feet and they'll move. And they'll move in ways that you couldn't even potentially get a microscope to move. It's just the angles and the rotation. So I'm in the exoscope race. I mean, I think that they're really going to be the horse to win, but ultimately they're all digital ways of seeing the same thing. To your question about 3D, I think Sam Barber's talk, and really the last slide was sort of pivotal. You know, these days everyone has their, Siri in their ear. They have their earbuds. We're constantly listening to podcasts. I think, Google Glass, the thing that went on the market, after the market, I think we're going to be constantly seeing, augmented reality. We're going to be used to things being in front of us all the time. And I think the 3D differentiation is going to sort of fade away because we're going to be so used to having things projected to us that. But
how can you use a glass with a magnification system?
So you could.
That could, that's a big headache, huh?
Well, I
think the glasses and the magnification system incorporated in the glasses. Do you think that's the future?
I associate some of this headache to buying a new pair of glasses. You buy a new pair of glasses, your prescription changes a little bit, and you have a headache for a couple days. But I think if you use it routinely, that sort of fades away to the background.
You get used to the headache.
Well, I don't know. I think you become used to it. No,
it's interesting, really interesting. It's astonishing. I think this is growing so quickly to all of us. So can you say about the 3D and the implementation and the system that you probably prefer?
Okay.
Leave endoscopes now, just for the end.
In my premium, limited experience, because you can see the pictures different. This is the exoscope, right? And it's homogeneous, the focus is the same. And also you can see the microscope. So you can see clearly just in the center. So I think it's the basis of the difference from the exoscope and the microscope. I think it's totally different. And about the endoscope and the exoscope, I think it's totally different because we can see deeply and we can wide angle from the endoscope. So I think maybe it's that.
So you prefer?
I prefer the two systems that maybe is cooperate. Yes.
Okay, Sam?
Oh, sure. So yeah, just a couple quick things. For 3D, I know just because I'm more of a junior trainee, when I get to the lateral skull base, I'm still really appreciating the depth that's involved. That is quite a fund of knowledge to get. So I think the 3D for me, like currently, is extremely helpful until I just have that fund of knowledge where I can rely on monocular cues for some of the more difficult approaches. other than transcanal. But I think in terms of one thing that was touched on yesterday that I feel like people should be aware of, this race for 4K, 8K, 16K, or 100K, however many K we need. But I don't think that it's actually just for clarity for a particular image, because that's going to exceed what's resolvable by the human eye. But it reminds me of back when digital SLRs were actually getting good enough to do large prints. And this is, if you're able to remove the optical zoom, but you have enough pixels for a crop factor, then you won't get pixelation. You won't have to have this interpolation of pixels, and you won't have a degradation of quality. So like back many years ago, if you try to crop an image from your digital camera, you couldn't even make out what it was. And then now, I mean, you can, even on a phone, you can take a small snippet of it, and it's like a full-size image. So I think, by going up to 16K, it's not overkill if you're using it for that sort of purpose. And I think one other advantage, if you remove the optical zoom and you have a fixed prime lens for the exoscope, that makes it a lot easier from a design standpoint for navigation and tracking, because you don't have to account for all of the different zoom factors as well.
Okay, this world is growing very, very quickly, and we'll see a lot of changes in the near future. Is there any question from the audience? We have very quickly. Yeah, please.
There are optical limits to depth perception. So the distance between the cameras and the distance from the object you're looking at. Have you anybody noticed any differences in your perception of depth depending on where the camera, the exoscope, is in relationship to the patient, the distance to the patient?
Anyone wants to answer?
I have not personally. I mean, we're not supposed to name brands, but some of them, based on the optics, you sort of have to put it in a certain position because of the light. So the lighting also plays a certain role in this and how much is being spread. So if you have the system that's too far away, it can be a little bit dark. So it doesn't exactly answer your question.
Yeah, but it's interesting, because sometimes some of the systems allow you to put until 55 centimeters, others 65, and ideally you should have it even far beyond, because otherwise you are always touching or the nerves, even when you're given the instrument. So economically it's difficult to adapt, but probably this will improve. But now it seems that there is a limit in the distance, in the depth of distance. Okay. I'm so sorry. I think we have to end this session. Thank you, all the panelists, and thank you for coming. Thank you for coming.